So now that we understand how to find the critical value, the t sub alpha over 2 from the t distribution table, and again, we use this when standard deviation is not known. Now we can actually go ahead and create a confidence interval estimate for the mean. Again, rather than just using a point estimate for the mean and saying that the mean is some value, which we do have that, we're going to take it a step further. Let's create an interval saying that the mean is this, but give or take a margin of error. So we're going to create that confidence interval. So we're going to use the 15 birth weights of girls given below. So here we have an original data set. So in this case, we can take our calculations to one more decimal place than the original data set. So we are, just like we have for measures of center and measures of variation, we could take our calculations to one more decimal place. So we're given the following. If we're talking about birth weights of girls, we're really assuming that this is going to follow a normal distribution. So this is really kind of a case where we can sort of intuit it. But I've put this here in case we weren't certain. So this is from a normal distribution. And so with n being less than 30, we needed to meet this requirement. We have the mean given. We have a standard deviation, but lowercase s. So this is from a sample. So in other words, standard deviation for the population is not known. It's probably worth noting this. So we're asked now to construct a 95% confidence interval estimate of the mean birth weight of the total girls. So it's kind of nice. We already did the work of figuring out our t value. Let's maybe look to our formula page to see what margin of error we're going to calculate. If we wanted, maybe we go ahead, since we're asked to construct a confidence interval estimate of the mean births, we should be able to see that this is the confidence interval we're talking about. In other words, the sample mean minus the error, and the sample mean plus the error is our min and max values for our confidence interval. And we're assuming, again, that these confidence level, or these confidence values, max and min, are going to capture the population mean here. So we know what the mean is for the sample. We need to calculate E. So we're going to rewrite the formula, but a little bit differently. Again, if we don't know the standard deviation for the population, we're going to have to use the t distribution critical value, or the t value. So, and the formula, notice, is a little bit different on our formula page. Here we see that the sample standard deviation is divided by the square root of n and then multiplied by the critical value. So in this case, we already found the critical value of 2.145, and we can multiply that by the 2.9, the standard deviation that was given, divided by the square root of our sample size, 15. Now, where we had to use the degrees of freedom of 14 to find our critical value, we're still going to use n as 15, because n is 15. It's the degrees of freedom for reading the t distribution table that is 14. Okay, so where degrees of freedom might be 14, n has not changed. N is still 15. So from here, why don't you take a minute and just finish out this calculation. So when I calculated, I got a margin of error of 1.606, or in other words, 1.6 if we take it to 1 standard deviation. And then we can use that to plug into our confidence interval, sort of set up a formula. Now, of course, you don't have to use this one. You could use the x bar plus or minus the margin of error. But again, sometimes it's actually nice to see those minimum and maximum values. Or if you have those minimum and maximum values, you could also set it up as an interval with the minimum value here and the maximum value here. So if we plug in, though, we're doing the mean of 30.9 minus the 1.6, and we're saying that that value should capture our population mean between that low value, which goes to 29.3, and our maximum value of 30.9 plus the 1.6, or in other words, 32.5. So what are we concluding? We're concluding that we are 95%, and that's a 5, confident Not that the mean is going to fall within our interval, because we're not calculating the mean, we're calculating the interval. So we're 95% confident that the interval of 29.3 up to 32.5 will either, we could say, capture or contain the population mean. We could also say that we would expect that our interval will capture the population mean 95% of the time.